this pandemic is the worst we have ever seen till now.
15 months, 147 million cases, and 3.1 million deaths later. Coronavirus continues its rampage. One virus has changed our world forever. But over the course of its devastating journey, the virus itself has changed. This is not the same strain which exploded in China in early 2020. SARS-CoV-2 is mutating. Multiple mutations of the virus are called variants, and these variants are worrying health experts. Can the coronavirus develop an anti-vaccine strategy? Will the COVID vaccines be as effective on these mutant variants? Why are all these double and triple mutants more dangerous? And is the pandemic's worst yet to come? Why does a virus mutate? Mutation, a word that has become synonymous with fear amid the coronavirus pandemic. The COVID-19 virus is spreading at an alarming rate and killing more people. And that's not because the virus is out of control. It's happening because the virus's mutation is proving to be hard to control. The new coronavirus is an RNA virus. It's a virus that has ribonucleic acid as its genetic material. Human diseases caused by RNA viruses include the common cold, influenza, SARS, MERS, dengue virus, hepatitis C, hepatitis E, Ebola virus disease, rabies, polio, mumps, measles, and COVID-19. RNA viruses have high mutation rates, and SARS-CoV-2 is no exception. It has been mutating ever since it was first identified. Many of its variants have emerged and disappeared in recent times. Some even went undetected, but there are some that can continue to persist. A virus mutates when there is a change to its genome, the set of instructions that contain the information it needs to function. Mutation occurs when the virus is inside a host, like a human body, and begins to replicate. During replication, the genome is copied. Sometimes there's a mistake in the copying process. Where the mistakes occur within the genome will determine the impact on the virus's ability to survive or continue to replicate. And that's the biggest challenge for the vaccines we have. Can COVID vaccines fight these evolving variants? All viruses go through some form of mutation. Some viruses mutate faster than others. Mutation could make a virus weaker, or it could lead to changes that encourage infection to spread. In India, it has become deadlier. Scientists have tracked multiple mutations of SARS-CoV-2, the virus that causes COVID-19, since it appeared in China in late 2019. India's battle with the second wave of COVID-19 has put the focus back on mutation. Experts believe that triple mutant strain or triple mutant variant is the reason for the recent spike in cases.
We've seen a systematic increase in cases across India, more or less taking off at the same time, suggesting that what might be happening is that something that is more transmissible between people is very rapidly moving through the population of people who are yet to contract the infection and therefore spreading faster. But I think we can be a lot more sure now than we were a few weeks ago that it's a double mutant that is driving this very sudden spike in cases.
Can you guess how many mutants have emerged since the coronavirus began its rampage? The figure may surprise you. Last year, in a study conducted using genomes from 46,723 people with COVID-19 from 99 countries, researchers identified more than 12,700 mutations or changes in the SARS-CoV-2 virus. Among more than 12,706 mutations identified, some 398 appeared to have occurred repeatedly and independently. Of those, the scientists focused in on 185 mutations, which they found had occurred at least 3 times independently during the course of the pandemic. So what's the difference between a variant and mutant? A mutant is the result of a mutation, a change in the genetic material that produces something new. The genetic material of SARS-CoV-2, the coronavirus that causes COVID-19, is called ribonucleic acid, RNA. To replicate SARS-CoV-2, RNA must hijack a host cell and use the cell's machinery to duplicate itself. Errors often occur during the process of duplicating the viral RNA. This results in viruses that are similar but not exact copies of the original virus. These errors in the viral RNA are called mutations, and viruses with these mutations are called variants. Variants could differ by a single or many mutations. The new ones are similar to the original virus, but not a replica. These days, the most alarm is being caused by 3 variants of SARS-CoV-2 that are spreading among global populations. The UK variant B.1.1.7, the South African variant B.1.351, and a variant discovered in Brazil known as P1. Each contains several different mutations. Just a few weeks after SARS-CoV-2 was identified in China, around the beginning of February 2020, a new variant called D614G superseded the original strain. It was this new version that infected much of Europe, North America, and South America. The D614G mutation was prominent in India too during the first wave of the coronavirus pandemic. Studies in human respiratory cells and in animal models demonstrated that compared to the initial virus strain, the strain with the D614 substitution causes more infections and transmission. And then in August and September, a SARS-CoV-2 variant linked to infection among farmed mink was noted in Denmark. Known as Cluster 5, it emerged among mink farmers in the Scandinavian country. It was reported that the virus was spreading from minks to humans via mink farms. In November, the government announced that the mink population in Denmark would be culled to prevent the possible spread of this mutation and reduce the risk of new mutations happening. A lockdown and travel restrictions were imposed in parts of the country. The World Health Organization stated that Cluster 5 had a moderately decreased sensitivity to neutralizing antibodies. The mutation came about at a time when the world was still trying to find a coronavirus vaccine. Soon, mink farms in Italy, the Netherlands, Spain, and Sweden also reported the Cluster 5 variant. Following the strict quarantines, lockdown, a mink euthanasia campaign, and mass testing, by November 19th, Denmark announced that Cluster 5 in all probability had become extinct. Even the United States confirmed cases of minks getting infected with COVID-19 in Utah in August 2020. Additional outbreaks were detected in Michigan, Wisconsin, and Oregon. Cluster 5 may be gone, but it created panic across Europe. On November 7th, the United Kingdom announced that it will also prohibit entry by non-residents traveling from Denmark and non-residents who had been to Denmark within the past 14 days. British citizens will still be able to return home, but they, as well as all other members of their household, must self-isolate for 14 days. This travel ban was to be reviewed after a week. The restrictions were eventually lifted on November 28th. And then by December, when vaccines such as Pfizer, Moderna, Oxford, AstraZeneca and Sputnik V claimed success, came the news. A new variant, B.1.1.7, was detected in the UK. In Britain, it was also referred as the UK COVID-19 variant. It is sometimes called the Kent variant, named after Kent, where the variant was found. The researchers believe this strain can spread more easily between people. It raised alarms whether this COVID-19 virus will be able to escape from the protection that vaccines were about to provide as they prepared to roll out. The variant has also been found in the United States. UK officials tightened lockdowns in England, Scotland and Wales, and over the Christmas holidays, more than 40 countries banned travelers from the region, in an effort to keep the new strain from spreading to other parts of the world. There was a clampdown on celebrations and social bubbles were created. The world was bracing for another evolution of the coronavirus. While the UK has tamed the spread of this variant, it caused havoc in the other parts of the world. In Asia, around 40% of the cases are said to be of this variant. Reports say this variant could be partially refueling the surge India is witnessing right now. In the month of December 2020, health officials were also concerned about a different strain found in South Africa that could become more resistant to vaccine protection. This was called B.1.351. This variant includes a few mutations in key areas that antibodies generated by the vaccine target. Detected first in the Eastern Cape province of South Africa. Researchers stated that prevalence of the variant was higher among young people with no underlying health conditions and more frequently causes serious illness in such cases than other variants. The variant is also said to spread faster than other earlier variants of the virus. On December 23, 2020, UK Secretary of State for Health Matt Hancock announced that 2 people who had travelled from South Africa to the UK were infected with B.1.351. Another mutation in this virus, called E484K, could help the virus dodge a person's immune system. This affects how well coronavirus vaccines work in suppressing it. Johnson & Johnson, who held trials for its vaccine in South Africa, said that the level of protection against moderate to severe COVID-19 infection was 72% in the United States, but it was only 57% in South Africa. Oxford AstraZeneca too did not have the desired effect on this variant. More than 80 countries have been affected by this variant.
There is increased transmissibility in the B.1.1.7 and the B.1.351 virus variants. And this is resulting from a mutation that allows this virus variant to bind to the cell, the human cell, more easily. We do not see an increase yet in transmission with the P1, but that is currently under investigation.
Another variant that has reached several counties is the Brazilian virus, P1. This variant of SARS-CoV-2 was first detected by the National Institute of Infectious Diseases, Japan. 4 people who had arrived in Tokyo having visited Amazonas, Brazil, 4 days earlier were infected with this virus. The variant caused widespread infection in early 2021 in the city of Manaus, capital of Amazonas. This is after the city had already experienced widespread infection in May 2020. The study for this virus is still underway, but experts believe that P1 infections can produce nearly 10 times more viral load than in other COVID-19 infected persons and showed 1.4 to 2.2 times higher transmissibility. It is infecting younger humans and can be 10 to 80% more lethal. It is also believed that the virus variant is capable of evading 25 to 61% of immunity from previous coronavirus diseases, leading to the possibility of reinfection.
We compared the samples and saw that the Amazonian samples were predecessors of the variant found in Japan, but were genetically distant, and that drew a lot of attention. It is possible that the Brazilian variant is more contagious. There is such a possibility because of the E484K and N501Y mutations, which have been associated with a higher transmission potential, so most likely it is more contagious.
These rapid changes in the virus brings us to the most important question. What are the major consequences of variants? A new variant can increase transmissibility and has the ability to spread faster. It can alter disease severity, either make it milder or increase the seriousness of it. It may reduce response to treatments and medications currently used to treat COVID-19. Some variants can lower detection by viral diagnostic tests. Variants can also improve ability to evade natural or vaccine-induced immunity. All these factors are being seen in India right now.
The variants that are important are ones that have changes in the way that the virus behave. Either they may have increased transmissibility, they may cause more severe disease, or they may have some kind of impact on the workings of our diagnostics, our therapeutics, and vaccines. If any of the variants have any of those changes, those are variants of concern, and we need to make sure that we study those appropriately and that any changes that are needed in our public health and social measures or in the way that we develop our diagnostics or the vaccine composition are informed by our understanding of what those changes are.
On October 5th, 2020, a double mutation variant was detected in India. It was called as the B1617 variant of SARS-CoV-2. The variant was considered more transmissible than previously evolved ones. Only a few cases of B1617 were known until early February 2021, and then there was a significant increase. By mid-April, India was in the midst of a COVID storm. Surveillance data from the Indian government's integrated disease surveillance program showed that a higher proportion of asymptomatic patients were admitted during the second wave, with more complaints of breathlessness.
The fact that this variant is increasing in its proportion, that's what makes it in the category of variant of concern, because this is increasing in its ratio in Maharashtra and in many other places. And therefore, even if it is not more dangerous, if it's not more troublesome in many other ways, it is certainly is better in terms of spreading compared to other variants, and therefore it's of concern because more mutation can build upon this and they can be a problem. So that is why any mutation which is increasing its footprint in the population is considered a variant of concern.
The variant caused an international alarm. At least 14 countries imposed travel bans and restrictions on passengers from India. And then there is this triple mutant variant. As India grappled with an unexpected wave, the term triple mutant variant started surfacing. Many thought this variant was responsible for the healthcare crisis. The double mutant in India carried two mutations, E484Q and L452R. When the two mutations bind together, they could modify the structure of the spike protein in unanticipated ways. It can also escape antibody capabilities. This new strain has been found in samples from the Indian state of West Bengal. Researchers in India say the new threat may affect vaccine efficacy, but more studies are needed. Can India's two vaccines, Covishield and Covaxin, counter this second wave? Indian Council of Medical Research found that Bharat BioNTech's Covaxin were able to neutralize B1617, although with a lower efficacy. In another report by Hyderabad-based Center for Cellular and Molecular Biology, it was revealed that people who have been vaccinated with Covishield have protection against the double mutant variant. Other pharma companies, too, are now studying this variant more closely.
This is something where we're still gaining data on a daily basis. But the most recent data was looking at convalescent sera of COVID-19 cases and people who received the vaccine used in India, the Covaxin. And it was found to neutralize the 617 variant. So despite the real difficulty that we're seeing in India, vaccination could be a very, very important antidote against this.
We are still testing the variant that has been detected in India, but this variant has mutations that we have already tested for. Our vaccine works against these mutations, so I'm confident about them.
It's the second year of the pandemic. It's the second wave in India. Brazil is in crisis. France and Germany have entered into another lockdown. All hopes rest on the success of the COVID vaccines. The fight is no longer only between humans and coronavirus, it's now about vaccines versus mutants. But there's no reason to panic. As we've shown you today, viruses are always changing, acquiring small mutations in their genetic material over time as they spread among people. Viruses mutate naturally as part of their life cycle and rarely impact outbreaks dramatically. Scientists are racing to update existing vaccines in order to make them a better match for these dangerous variants. Meanwhile, citizens need to do all they can to break the chain, and that means following quarantine rules and getting their vaccine shots.